Hey guys, so today we're going to take a look at the rock cycle, but instead of using real rocks, we are going to be using Starburst candy to model rocks and the processes that they go through during the rock cycle. So over time, our rocks here are going to undergo a series of processes called weathering and erosion. So during weathering, the rocks get worn down, and erosion, they get washed away. This weathering and erosion causes sediment, which is represented by these little pieces of starburst here. And over time, the sediment settles and gets buried under layers and layers and layers. In order for sedimentary rock to form, the sediment has to undergo quite a bit of compression. Let's see if we can spell that out. So it gets compressed or smushed down, right? And then it gets cemented together. So let's see if I can model that for you now. All right, here I am compressing our sediment. And as I am doing that, it is getting sort of cemented together until it is one piece. Now, if this were a rock out in nature, I would actually call this conglomerate. Let's see if I can spell that. Oops. Conglomerate. And that is sort of a messy bundle of sediment right here. Another type of sedimentary rock would be more like this structure right here. You can see that the layers are, oops, we're getting a little trouble with focus. The layers are sort of stacked and smushed together, and this is one piece, right? So our sedimentary rock can be kind of clumpy, like a conglomerate, or it can be nicely layered like this, which might be sandstone or another structure. From here, if our sedimentary rock is to become metamorphic, it needs to be exposed to extreme heat and pressure. And that, heat and pressure will turn this rock into a metamorphic rock. So here's what I'm going to do. I am going to take my samples here, and I'm going to put this piece of wax paper over one of these samples, and I'm going to pick it up and start applying pressure from my hand. Now check this out. I kneaded these with my hands for a couple of minutes by putting a lot of downward pressure, kneading it really hard, and the heat from my hands produced the heat I needed to sort of soften the rock. It did not melt, but it softened. And the pressure from my hands caused it to change shape. So look what happened. Those nice layers that we had are now sort of twisty, right? That looks a little bit like gneiss. And over here, our conglomerate kind of got smashed together here, and we have these large crystals, which might be some other type of metamorphic rock. So heat and pressure have changed these from sedimentary into metamorphic rock. Now, in order for these beautiful metamorphic rocks to become igneous rocks, what needs to happen? Well, remember that igneous means fire, right? So these rocks are going to have to be melted, right? And when they are melted, they turn into magma. And when the magma cools, we will have igneous rocks. So here's what I'm going to do. I have this little tinfoil tray. I'm going to put these rocks in there, and we're going to take it to the stove and melt it down. Okay, I've put my metamorphic rock onto this heat source, and it actually might be a little bit too hot, but you can see that it is starting to melt and break down, and we'll check back in. All right, we can see here that it is bubbling and oozing, just like magma would be under the earth, but it's still not completely melted yet. Okay, there it is. Our rock has officially melted into magma. So in order for it to become igneous rock, this magma needs to cool. So we're going to set it aside for a few minutes and see what happens when we allow it to cool. So there it is. Look at my really cool igneous rock here. Let's label that so we know what we're looking at. So look, along the outside, you can see that it is pretty uniform. There's not a lot of crystal structure. So this is probably more like obsidian. That's that glass-like volcanic rock. But if you look closely in the middle, and I can't put an arrow there, but in the middle, you can see some of the big minerals in there that have sort of clumped together, and that would be a larger crystal size. So the stuff in the middle there, I'll do my best, is probably more like granite or something like it, right? And granite cools slowly. So we have larger crystal sizes, right? And obsidian is going to cool quickly. And as a result, we don't have those big crystals. We have more of a smooth surface. Pretty cool. So today in our example, we went from some type of rock here, right? We didn't specify what type it was, but we started with sediment right here. And then we formed sedimentary rock. And then from sedimentary, we went to metamorphic. And from metamorphic, we went to igneous. But that doesn't have to be the order of the rock cycle. The rock cycle can go in any order. It could go from sediment right to igneous, or sediment right to metamorphic, etc. So the other thing is, if we start looking at my igneous here, you can see that it's already coming apart. It's already weathering and eroding. And so it's getting ready to start this process all over again. Therefore, we call it the rock cycle.